so welcome back. So we were talking right before the break about requirements on transportation fuels. And we concluded that for transportation fuels, the only elements that really work are carbon and hydrogen. You can put a little bit of oxygen, a little bit of nitrogen in, but basically it has to be carbon and hydrogen. And you could, if you choose any other elements, you're going to end up with either solid or toxic products as the main product from the combustion. And so that's going to be a problem. And ideally, you want this to be a liquid or gas, since we decided we really don't like solids. But when I do the analysis, you're basically stuck with carbon in the fuel. And so you're going to have a CO2 as a major product. And CO2 is the main greenhouse gas. So this is really not looking so good. So then it makes you think, maybe we need to reconsider relaxing our requirements and what we require on a transportation fuel, because the straightforward analysis says that you have to use hydrocarbons, and but we know that hydrocarbons are the main problem for the climate problem. So what to do? So that's the question. So we want a transportation fuel that reacts with oxygen. Its major oxidation product is non-toxic gas or liquid. It has an energy density of at least this, and this much energy density by volume. And you want it to be not turn into a solid down to -20. And you don't want the major oxidation product to be a greenhouse gas. But it appears that there is no such material. It's like just not possible to have a material that satisfies all 5 of those requirements. So the question for you is, which of the requirements would you relax? Because we apparently cannot satisfy all these constraints. It's a null set of possible things. So that's a question for you guys. Which requirement would you give up? The 4th one, you say it's okay if it doesn't stay liquid or gas down to -20.
Compared to all the greenhouse gases, and it's better being non-toxic and not a greenhouse gases.
Okay. So
the climate change is the only thing.
In the back she says, okay, well, we don't want to kill anybody, so we don't want it to be toxic, so that one we got to keep. And we really don't want the climate effect, so we don't want a greenhouse gas, so we got rid of that. We're going to keep number 5. So she says, let's consider relaxing number 4. So relaxing number 4 is possible. It's a big problem for aviation because the temperature up at the altitude where the airplanes fly is down in that kind of temperature range. And so you can imagine the operational problems you might have on an airplane. Yeah? How to get this CO? Yes. Okay, so another one is get the carbon, don't use fossil carbon. So somehow get the carbon some other way, and then you could stick to hydrocarbons that we like. We just now somehow avoided the fossil carbon problem. That's definitely a possibility. Yeah? Okay, so you could say, let's not bother with the reaction with oxygen. So then you'd have to have maybe 2 things you'd carry, and they react together. That's definitely a possibility. You have to think pretty hard about what you have that's better as a co-reactant than oxygen. But there might be something. It's definitely worth a thought. Yeah? Okay, so you think try a mixture. So you'd have something that's high energy density with something else that's lower energy density, and then together would the overall energy density still be good enough? Is that the idea? Okay. So that's a possibility. So you could have like some hydrocarbon and mix it with something that doesn't have that energy density, but cumulatively together has a total high enough energy density. That's a possibility. Back corner?
So that you don't have too much mass and too much weight, which increases drag. But if you have a fuel that's environmentally sustainable, it isn't toxic, and you have a lot of it, it doesn't really matter if you have more drag because you can just burn more of the fuel. So maybe that could be
That's a possibility. I think that an issue with this, sorry, let me repeat what she said. So the idea is that if we had an environmentally sustainable fuel, we could just use a lot of it. And so we don't mind if we have to keep refueling or have a big giant fuel tank because we don't care how much we use because it doesn't hurt the environment. I would say that that's a good concept. I think that the downsides with this, there's kind of two of them. One is this issue that the vehicle often is more expensive than the fuel. So in an airplane or a ship, if you need to make the airplane like much fatter to carry all the extra fuel, but it only carries the same number of passengers, it's going to make the airplane more expensive because it's like more titanium or aluminum or whatever they use, carbon fiber, to make the airplane. Or alternatively, you could squeeze the passengers out and use more of the passenger space for the fuel, but then you lose revenue from selling tickets. So I think to those industries, they would be very frightened of the solution. But it's not like it's impossible. It just means it's more of a challenge for them. I think there was another question in the back.
Yeah, but only for the volume part. You will just figure out a way to store hydrogen and figure out the ortho-para conversion stuff and just keep the energy density in terms of mass, because that's what you
Okay,
need.
so yeah, so one idea that actually people are pursuing is to try to use liquid hydrogen as the fuel. That actually achieves the volumetric target. It introduces a lot of additional problems about having to handle something at negative, whatever, 20 degrees Kelvin or whatever the temperature is for liquid hydrogen. And I would say to me, it's ridiculous, but a lot of people think it's a good idea. And so I know Airbus has like a project to try to actually make an airplane like that. And so maybe it'll work. I don't want to naysay any other engineer. They could think of a clever way to make it work. Yeah.
This may downstream sequestration processes better.
Yeah, so that's actually, okay, that's good. So another suggestion is keep these great requirements because these are excellent for transportation and solve the problem some other way. And so one way some people say is, well, let's just use direct air capture and just take the CO2 out of the air and sort of have the cost all on the cleaning the air part, and the transportation sector can go ahead and do whatever it wants to have these nice, wonderful fuels that are super easy to use for all our vehicles. I think that's, there might be some economic sense to that suggestion. Practically or politically, it has a problem that it's like, it's going to be a lot of money for the CO2 capture part. And so somehow, I think society is going to expect that the transportation guys who are emitting a lot of CO2 are going to have to somehow transfer a lot of money to this other sector that's doing the cleaning up part. It's not impossible, right? You could imagine some fuel tax that somehow directly goes to fund the cleanup or something. So it's possible. It's pretty different than what we're doing right now, I would say. So this one gets to be maybe not so much an engineering challenge, but more a human institution challenge of how you would set such a thing up. But it's possible. Yeah?
Maybe the fourth one, like having a secondary system that guarantees like the fuel is above like the minus 20 degree. Like
So
having
like
a heating system.
Like have a heating system when your fuel tanks and stuff
Right.
yeah, that's definitely a possibility, right? So you could have it, you'd have to have like a redundant thing or something, right? So you don't kill the pilot of your airplane when the fuel freezes. It actually has happened that truck drivers are frozen to death in Canada in the winter if their truck fuel froze. So it's not like completely unrealistic, but of course in many countries it never gets that cold and you wouldn't worry about it. Right? Yeah.
Seems overly restrictive. I think we could tolerate some products that are greenhouse gases, but either at a lower global warming potential in the product or like lower global warming potential per energy produced.
Okay, so the suggestion is to try to find, like, say, it doesn't have to be zero greenhouse gas, but some attenuated greenhouse gas or not such a bad greenhouse gas or something like that, or not as much carbon dioxide or something. And maybe this is related to the idea somebody said about a mixture, that you can have a little bit of hydrocarbon and with something else, and so your total CO2 emissions is a lot less. It's a possibility. All right, I better keep going on. Thank you. Those are all really good thoughts. and I would say that I think almost all of them are actual policy proposals or technical proposals that, like, grant agencies are funding and people are trying to figure them out. And I think the fact that all those things are still in play indicates how difficult this problem is and how much it's unclear, like, what's the real way out of this conundrum. So it's like a real challenge for your generation, I think. It's like, we have to solve it. I can tell you why it's not going to work. That's what my slide is here. You guys prove me wrong and show you can find a way around what looks like an impossible problem. Let's talk about more about transportation fuels, which today is petroleum, and how much do we need, and how are we using it? So right now, about a quarter of the petroleum in the world is used to run cars and buses, things that carry people on the roads, mostly cars. And then about 18% is used to run trucks that carry freight. And then we have about 6% each for ships and airplanes. And then there's actually other uses of petroleum, like they make chemicals and a lot of other stuff that I'm not going to talk about. But these are, these are the end uses that the transportation fuels are really concerned about. And I just wanted to get the idea that it's not just cars. Cars are the biggest, and particularly in a place like the United States, where it's very car-centric culture, cars are very important. But there's a lot of countries in the world where not that many people have cars, and it's relatively small potatoes. It also has to do with how your towns and cities are set up, how much you rely on cars, maybe also what the weather's like, too. And then some of these, actually these three, well, at least road freight and aviation are predicted to increase really significantly in the coming years in the total amount of petroleum required. Because as people get richer, they like to take airplane flights. And also, as societies get richer, they have more goods to ship. And more consumers want to buy more stuff, and so you use more trucks. So these two are likely to increase a lot. I think people expect that this one's going to go down because electric vehicles and more efficient vehicles like hybrids are coming in, and they're going to reduce the amount of gasoline it takes per mile significantly. So this one is likely to actually become a smaller fraction of the total petroleum. But the fact that these two are really going to increase, and then depending on what happens in international politics, the economy would say that the number of ships would go up a lot too, but bad international politics and tariffs and stuff might stop it. So I think it's really unclear what's going to happen with shipping. And each of these have different kinds of engines, and they currently all use different fuels, right? We use gasoline, diesel, bunker fuel, and jet fuel, and they're all different. And probably in the future, there's going to be even some other different thing, whatever you guys invent, to solve all these sectors. And then each of the new fuels will need engines that match it. So you can see there's quite a lot of development to do, figure out which fuel we're going to use, how to make that fuel, and then what engine matches with that fuel for the particular use case. With petroleum, people decided that we needed different fuels for each of these things, and presumably that's also going to be true with whatever the new fuels are. So the current consensus view, I think, is that a lot of the new cars and light trucks are going to switch to be battery electric. And as the prices of the batteries go down, this is getting closer and closer to reality. And then in some countries, like China, they have really strict restrictions that are forcing it to happen. But even in the other countries, it's also happening just because of cost competitiveness of the battery vehicles. And definitely it's believable that this is going to be really big in a lot of countries. There will probably be some cars left that don't use electricity, either in countries or places where the electricity recharging is not convenient, where people that need to travel really long distances and can't spend the time to charge. So there's, I bet, and also used cars, old cars that are still using the old gasoline will still be around. So there's going to still be a lot of gasoline used, but potentially it could go down quite a lot as the battery vehicles come in. Jet planes, the consensus right now is they're going to keep on using jet fuel. And the idea is that this fuel is going to be made some other way, either from biomass or from CO2. That's going to be expensive, but I think the theory is that the cost of running an airplane is mostly the cost of the plane and of the labor. And so the fuel cost, although it's significant, is not enough to prevent this from happening. So maybe the ticket prices will go up some, but they won't double, and people will be able to use a clean fuel. Super unclear what's going to happen to ocean-going ships. This is actually the sector that's most fuel sensitive of all of the sectors. They use a really huge amount of fuel, and in fact, they scrap their ships to get a more efficient, fuel-efficient ship, because the fuel cost is actually very significant to them. And one idea is if you have enough biomass or enough CO2 captured, you could make carbon-containing fuels and keep running the same engines you have today. Another idea is you'd have ammonia. A third idea is people think that they can make methanol and use somehow in a clean way, and then they would use the methanol. This is really super unclear. And historically, this is not a well-regulated sector. So it's also not clear that regulation could force what they could force to happen, because it's international and international waters mostly. So that's also completely, I would say my generation has done nothing to solve this problem. So totally up to you guys to figure out what to do about that. Though I'd say on the good side, the International Maritime Organization recently passed some pretty progressive targets of what they want to do. So there's like I'd say the slim majority in that organization wants to clean it up. But there's a significant minority that are running old ships and don't want to change. So they have quite a political fight. And it's super complicated because all the countries are involved. Yeah?
So even with the previous graph, wouldn't it be fair to represent the whole cycle of the battery and the electricity production necessary to power the batteries?
Yeah. So right now, the petroleum is used, a quarter of it for the road vehicles. The amount of petroleum that's going to go here is going to go down, but there might be a lot of other energy in mining and production of batteries, and also in making the extra electricity to drive all this energy. And so it's super unclear what's going to happen to the electricity grids to match this. This is quite a gigantic amount of demand increase for electricity that's implied by, if you suppose you would cut this in half, that would be a huge amount of electricity that you need. For it to be really clean, you want a lot of that electricity to be coming from solar or wind or nuclear or hydro. And is that going to happen? I don't know. But that's, or maybe with CO2 sequestration from fossil fuel. I don't know. So I think this is like also completely up in the air. Many countries are worried about this, that they have electric grids, legacy electric grid, whatever they have, of whatever power sources their countries decided to put in 40 years ago, 100 years ago, whenever they put electricity in. And they probably need to change, but what they're going to change to is really unclear, and who's going to pay. And then how much extra capacity are they going to build to power all the cars is also unclear. But yeah, but that's still, despite all those problems, that's still the consensus view of what's going to happen. Yeah.
From vapors goes down.
Yeah.
Isn't that going to be a problem also on the fractionation when you do distillation?
Yeah, so the question here is if you have anything that changes what happens to petroleum, because petroleum gets split up into all different fuels for different purposes, but all the petroleum in a barrel has to be used for something. So if you separate it and suppose the gasoline consumption went way down, the US refineries are all made to make tons of gasoline because that's what the market is in the US. They would all have to shift to make way less gasoline and instead to make a lot of something else. It's not always so easy because if you have small molecules, it's not so easy to make them combine to make bigger molecules or whatever. You could alternatively, you could switch the trucks to run on gasoline. That's also a complicated thing because, yeah, there's a lot of complications. So I would say the whole thing is super complicated. It's like first figure out what you even want to do and then how you would actually implement it. is not so clear, and it's almost like you have to work it all the way through and see, does the whole thing actually hold up? Just like with those constraints, I could show you like that nice slide, it shows it has to be carbon and hydrogen, and if you stop then you'd all say, okay, we're all done, we have hydrocarbons, right? And you never worry about the climate problem. So there's like extra constraints that you might not be aware of that either are firm constraints or just add a lot of economic cost to cross the constraint. And so that's not resolved either. And those of you who are chemical engineers, you might want to work in like refinery reconfiguration, because apparently that's a lot of things are going to happen there. If it switches to way less gasoline and way more diesel, for example, that's going to be a big change, and they're going to have to invent new processes and stuff to make that actually work. And somebody's put a lot of capital investment in. This is another huge challenge, is the more clarity there is about what the solution is, then it's safer to make a long-term investment towards that solution. And the more things are unclear, the more risk, which means that people typically don't want to invest a lot of capital because they're afraid that eventually things are going to change in a way that their asset that they invested in will have no return anymore. And so that's a big deal for refineries right now, because it's like nobody wants to put money in refineries because they're not sure what's going to happen. But then that means we're kind of locked into whatever stupid refinery system we have right now, just because that's what we have, right? And then it's really unclear about ships, and also I would say it's also unclear what's going to happen to trucks. So if you look at the EIA projections, they just say nothing's going to happen, and they're going to use diesel indefinitely. But then what happens in that scenario is that diesel becomes a gigantic fraction of all the CO2 emissions because it expands as the amount of trucking increases, and if it's all diesel, then it's a lot of fossil fuel. And as the other things all shrink away, it becomes like the sore thumb sticking out. And so I would say this is really unclear what's going to happen. But there's actually multiple options for trucking. It's not as difficult as shipping or aviation to solve. All right, so one idea that somebody raised was you could try to just make the hydrocarbons without using fossil carbon. And so there's a lot of interest in this. And as I said, this is the consensus view of what's going to happen for aviation, for jet fuel. And so you can start from biomass, and you could just use biomass straight, or you can have biomass where you supplement it with some clean hydrogen, or you can try to just make the fuel directly out of carbon dioxide. There's like 3 different concepts that people are playing around with. And then you can make different stuff. If you have these atoms, the hydrogen and the carbon, there's a lot of different ways you can combine them. And one idea is Fischer-Tropsch. And this was a technology actually developed like in Germany, I think during maybe World War I, maybe World War II, I'm not sure which one, somewhere around then. And basically it's diesel. And so you can just make diesel fuel directly, and people know how to do it, and it's commercial, and it's a possible thing to do. Another idea is to make methanol. Methanol seems to be cheaper to make than the other ones, than the other fuels, but we don't use methanol right now, and it has very high evaporative emissions, and it's toxic. So it's not that great, but it's super cheap to make, so it's kind of good. So this is there's a dispute in the literature where a certain group of people think methanol is the future, and there's been textbooks and stuff published as like methanol is the future, and other people don't like it. Another idea is if you make methanol because it's inexpensive to make it, you could then, there's a process called methanol to gasoline that you could use to convert the methanol to gasoline. It definitely works. It was commercial before when the economics were good at one time in the past. So they definitely know how to do it commercially. And so that would be another way to make a low carbon, potentially low carbon gasoline. But you take an additional cost going from the methanol to the gasoline. In all of these, and many others too, the clean hydrogen is typically the main cost in making the fuel. Blue hydrogen, where it's this hydrogen you make from fossil fuels, but you capture the CO2 and sequester it underground. That hydrogen is about as expensive per joule as petroleum, similar cost, maybe a little bit less than petroleum. Green hydrogen, where you make it from electricity, is at least 3 times more expensive. But people think it's going to go down and maybe get down to be close to blue hydrogen. This is completely unclear, I think, right now. But regardless of how you make the clean hydrogen, it's really expensive to deliver retail hydrogen. Hydrogen is a gas. You can deliver it in cylinders, or you can deliver it as a cryogenic liquid. Both ways are really not very great way to deliver it retail. So wholesale, you would definitely deliver it by a pipeline. So if you have a big giant consumer of hydrogen and a big producer, you just run a pipeline between them, and once you pay the cost of the pipeline, you're done. It's basically free to ship the hydrogen from the producer to the consumer. And you can do huge volumes. So if you want to decarbonize a petrochemical complex, you put a hydrogen production plant somewhere, and you run a pipeline to that complex, and that's it. But for transportation, where you need to have the fuel all over the place at many different truck stops, say, then all of a sudden the cost gets completely out of hand of driving little trucks full of little bits of hydrogen to all these different truck stops everywhere. After you do all this, it turns out to be quite expensive. And so today, there's some places in Germany, Norway, US, where you can buy hydrogen, but the cost per kilogram of hydrogen is like something like 7 times the cost of equivalent petroleum fuel. So it's a pretty expensive, and most of that cost is just the delivery cost of getting the hydrogen. It's not the production of the hydrogen, it's getting the hydrogen from the production plant into your vehicle at the pressure you need. People are working on it to make cheaper ways. It'll go down, but it's still going to be a significant cost. So what can we do? So we would really like to make these things called drop-in fuels, where you basically leave all the equipment the same way we have today. Same car, same truck, same airplane, same ships. And all you do is you come up with this nice jar of fuel and you pour it in, and it's magically doesn't pollute the environment, and it has no greenhouse gases, and it's great. And that way nobody has to buy a new vehicle, nobody has to put new refueling infrastructure. We can use the same gas pumps and stuff as we use today. And all you have to do is that the chemical plant has to change to make the fuel differently. And so this would be really great. It would save a lot of money. It would actually save a lot of time, because we already have all our regulations and taxes and everything are all set up around liquid fuel delivery. And we know how to handle that perfectly well. Safety rules, everything. If you make some new fuel, you're going to have to develop all that stuff again. All the regulations and safety and taxes and everything would have to be worked out. And at least in the United States, we're not that great at legislation. It might take a while. Some countries are a little bit more efficient. They might be able to get it faster, but not ideal, I would say. And some other countries are just as bad as we are in the US. So this is a great idea, but the main challenge is you need to get non-fossil carbon atoms into these to make these fuels. So there's kind of two ideas. One idea is to start from carbon dioxide. And the challenge with this is just stoichiometry, that for every carbon atom you have in the finished fuel, you needed 3 H2 molecules. You needed 6 H atoms for every carbon atom. 2 of those hydrogens probably end up in your fuel, and then 4 of them are wasted making water, because they have to react the oxygen atoms away. And so this is a pretty big problem. It's a lot of hydrogen. So this is the main cost is really dominated by all this hydrogen. So then people say, well, you can save a lot of hydrogen if you start from biomass instead. And so that's actually what most of the aviation people and jet fuels, they want to do. There's 2 concepts here. One is you either do it with or without hydrogen. With hydrogen, you need 6 moles of hydrogen per glucose unit in the biomass. Biomass is mostly a polymer of glucose. And so you need about 1 mole of hydrogen per mole of carbon atom. So it's a factor of 3 better than it was for starting from CO2. So way less cost for hydrogen. So this really gives a big price advantage for using biomass compared to using CO2 as your source of carbon. If you're really cheap, you don't add any hydrogen, you just use the biomass, and you do some water-gas shift reactions among the biomass to generate the hydrogen you need, and you can end up, what happens here is you lose carbon atoms, because you have to use some of your carbon to do water-gas shift, and so you end up emitting 1/3 of your carbon atoms in the biomass as CO2, and you only get 2/3 of the carbon atoms out as biomass. So you have a choice here of like how much hydrogen to use, which is related also to how much biomass availability you have. If you're short of biomass, you'd want to add the hydrogen, because then you get more fuel per ton of biomass that you put in, because you'd end up with 6 CH2s instead of 4, so 50% more biomass fuel for the same amount of biomass coming in. So today, you would not add the hydrogen, because hydrogen is too expensive. And so you would just try to make the fuel directly from biomass. And almost all the biomass units you've ever heard of, cellulosic biomass, it was kind of a thing for a while, is all based on this concept. Other people do gasifiers. Gasification of like wood chips is pretty popular in Europe. They have some units that actually do it. It was done, I think, during one of the world wars. It was also done. It definitely works. You can do it. And again, it has kind of lousy carbon efficiency, that a lot of the biomass carbon ends up as CO2 coming out. But it works, and you can make it. And you don't need any input. You don't need hydrogen. All you need is put wood chips in, and you get your fuel out. If you're in a place that has a lot of wood chips and not much money, that's the way to go. If you have a place where you have a lot of demand for fuel and you don't have very much biomass, then you'd want to add the hydrogen. And so my opinion is that this is what's going to happen. Yeah.
How much we are going to affect with the crop and the fertilizer, we are going to make.
Yeah, exactly. So my opinion is that the question was, if you try to actually do biomass to scale up, say, to the size of the whole jet fuel market, it's a lot of biomass. It's really a lot of biomass. I think there's enough, but it's like in the whole world, there's enough biomass you could harvest to provide just for the aviation fuel. It's not like just one country. The United States doesn't have enough biomass to supply all the jet fuel you need in the world. Yeah, it has to be sustainably harvested, right? So, U.S., we have very good agriculture. We have a lot of agricultural waste. We have pretty good forestry. We have a lot of forestry waste. If you add that all together, it's not enough carbon atoms for all of the jet fuel that we use every year in the world. So you'd have to also have, United States plus Brazil or something like that, right, to meet the demand. It's possible, but you can see easily that you're going to have problems with land use issues, because now you're using a lot of your capacity of your agricultural and forestry sector just to get this biomass and then trying to process it to make the fuel. And so my opinion is that if we do this, we'll probably do this hydrogen supplement method to try to get more biofuel per amount of biomass we put in. And even with this, we're not going to have enough. So probably people are going to actually do this other one here, but now I need 3 times as much hydrogen. This is going to get to be very expensive, really big money. Yeah?
So if you look at the literature, like there is like a big variability of the sources that you can manufacture the biomass. What do you think about this variability? Is it like something good for the industry, like to have like different sources?
No,
or
it's
like,
terrible.
So the characteristics will be different, and the device, like let's say like the biomass in India is different than the biomass in South America, but the same engine will be like manufactured in only one place and imported to the 2 different countries.
Yeah, so the question is, biomass in reality is super high variability. And even from the same plant, different parts of the plant are like really different from each other. And in different locations, they grow different plants and all different. And if we're trying to harvest like a significant fraction of all the biomass in the world to use for making fuel, you're going to have to deal with a huge variability issue. But the vehicles, the engines, they want the fuel to be the same. Right? I mean, they have some robustness, but not that much. They want the fuel to be pretty much the same, especially a jet engine. You just don't want to mess around with it, right? So you're going to have to do a lot of processing from the biomass to get to the finished fuel and certify that the finished fuel is exactly what you need. So from the point of view of the chemical engineers, I'm a chemical engineer, this is a total headache, Because like part of the year I'm processing corn stalks, and the other time I'm doing wood chips, and then some other time, I'm growing some energy crop or something, and then I'm importing some biomass from Congo. It's like, what the heck am I doing, right, to try to operate my plant? You can imagine, right? But, the climate problem is pretty big, so maybe it's worth the hassle. But it's definitely a hassle to figure this out. And then some people say, well, let's just intentionally do a monoculture and plant all these plants that are exactly the same that process really well. And definitely some plants process much better than others. But then there's like ecology problems. If you make gigantic pieces of land that are all in monoculture, you get like one plant disease, maybe it kills them all, right? And whatever it does to the native animals and plants that lived there before, you'd be totally screwed up. So I think this is a really super complicated issue, not the simplest solution. So from that point of view, CO2 is like way simpler, but it's way money. It's a lot of money. So anyway, that's the situation we are. Yeah, and I think how much supply of biomass is really realistically available really is not known that well. I think it's pretty clear there's enough actually to do the aviation sector, but how much left over there is to do everything else is really unclear. And the land issues are really, really complicated. Even what you want to accomplish is super unclear. And then after you knew what you were trying to accomplish, trying to actually make regulations and policies and taxes and subsidies that would actually make people behave to cooperate with what you wanted to accomplish is also super, super unclear, because the farmers and the foresters and the people who live everywhere have their own opinion about what they want the land to be like, and they might not go along with your plan. So this is not easy.
Implement this approach, meaning well, we are going to create a bigger problem. Like, for example, if you go with biomass, you have to use so much fertilizer that you may end up with more greenhouse gases.
Right. So yeah, so definitely a possibility you could really screw things up. Anything you do with land use, it's definitely possible to screw it up, and humans have screwed up things significantly many times in the past. I would say also that the system we have today is not necessarily best ever either. So I think trying to figure out what you would really want to do and then getting a societal consensus of what you want to do, I think this is super complicated. But I would say that most likely the farmers themselves will probably want to sell some of their waste, agricultural waste, to make the biofuels. It gives them more income, and it meets a societal need for the sustainable aviation fuels. So some of this is going to happen naturally. But as the scale goes up, it gets way more complicated. And also, once you leave the countries that have very strong regulatory regimes and you go to other countries with less, you definitely have the risk. You could have massive deforestation. You could have all kinds of bad stuff happen. It could get out of control pretty rapidly. So this is a very complicated one. All right, let's keep zipping along here. Now, you may wonder why I took all this time to talk about this big picture stuff when I should be teaching you chemical kinetics. And I just wanted to try to figure out how does this fit in? So there's no consensus yet for sure about ships or trucks, about what the fuel will be or what the engine will be in order to meet the greenhouse goals of the Paris Agreement. Probably we're going to need new engines and new fuels. This is like a huge challenge to figure out. We don't even know what we want, and we have to figure it out like pretty darn fast, right? Because many countries have net zero targets of 2050. If you're going to try to make a truck by 2050 and out in deployment, maybe you need a truck factory by 2040. So that's only 15 years from now. So this community has to figure out what is the solution for that really quick, and then work out all the kinks with the new engine and the new fuel really quick. So this is a huge challenge, and probably it's going to take a couple iterations of people trying new engines, trying the new fuels, figuring out it didn't work, how to make it better, just like we did with all the other engines and fuels we have. It wasn't just like one time and you made it perfect the first time. And so the society is relying on us, on the combustion community, to identify the replacements for petroleum for transportation, and in particular for ships and long-distance trucks, but also for other applications too. And we're kind of stuck. It looks like carbon and hydrogen have to be in the solution, but we have a problem. It doesn't work. And you could try other stuff, but they have problems too. And basically, there's a lot of different options, and we need good assessments of which of these options actually make any sense to work on. And then we need a lot of R&D for each of the different viable options, the things that seem viable, to figure out which ones are really going to work and going to be affordable and work robustly. Because society relies on airplanes, it relies on trucks. We can't have them that they don't work. It's not an option. And we rely on the society's engineers and scientists to solve problems like this, right? The regular Joe in the street is not going to solve this problem. It's like people in this room are going to figure this out. So that's the connection. And so the rest of my lectures are mostly all about how can we do the calculations to figure out if a particular fuel is going to work and exactly how to do it. And the predictions from the combustion chemistry modeling is really helpful when you have multiple fuels and engines to consider, because otherwise you actually have to build all these engines and make plants to manufacture all these fuels to do all this experimentation. It's really not that practical. So as much as we can do in the computer to try to guide the experimentalists towards the smart experiments is really, really helpful. So that's what most of the summer school is about. All right, so some key points. Today's energy system is based on burning carbon-containing fuels, mostly fossil fuels that release huge amounts of CO2 in the atmosphere. It's the biggest component of climate change. Most of the fossil fuels burn to make electricity or heat for industry or buildings. And primarily this is coal and natural gas because they're cheap. But the fossil fuels from petroleum are used primarily to power transportation. And we have to replace them both, right? So we need some kind of replacement for heat and for electricity, and we also need some kind of replacement for transportation. And probably they're going to be different solutions. In some sectors, there's some good low greenhouse technologies that are known, for example, for electricity production and also automobiles. But in the other sectors, basically, there's no consensus on what we should even do. So there's a lot of things that are wide open, really, really consequential, big issues for the world that are not resolved that we have to resolve. And that's it. And let's maybe break a little bit early for the break and then come back at 4:10.